In this video we're looking at 2022 paper 1 question 3 and it's all about complex numbers. The first part of the question is relatively straightforward. We're told that z is the complex number 6 plus 2i and we're asked to prove that this equation is true, that z minus I times z equals 8 minus 4i. So you simply sub in, instead of z on the left hand side, you sub in 6 plus 2i in each case. You multiply it out and you end up with 8 minus 4i on the left. So that's all we need to do for that one. It's relatively straightforward. In part 2 of this question, we're asked to prove the modulus of z squared plus the modulus of I times z to be squared is equal to the modulus of z minus iz to be squared. We know we're given z is 6 plus 2i. If you take z and you multiply it by I, you get 6i plus 2i squared. Remember that 2i squared is equivalent to just minus 2 because the I squared becomes a minus 1. And the right hand side, we've already worked that out in the previous part of the question. Z minus iz is 8 minus 4i. On the next line, I'm dealing with the modulus. Remember that the modulus, to work out your modulus, it's the square root of a squared plus b squared, where a is the real number and b is the coefficient of I. So to get the modulus of 6 plus 2i, it's the square root of 6 squared plus 2 squared. This one is the square root of minus 2 squared plus 6 squared, and this is the square root of 8 squared plus minus 4 to be squared. Now, if you simplify this, I'm just simplifying inside the surds in this case. You get the square root of 40 to be squared, you get the square root of 40 to be squared equals the square root of 80 to be squared. Now obviously there's a square root and a squared in each term and they all cancel out, so you end up with 40 plus 40 equals 80. Obviously that just means 80 is equal to 80, which is true. Now you have to put your thinking cap on for part 3. We're given a circle and we're given a number of points on the circle. I know that the point Z is on the circle, the origin is on the circle, and the point IZ is on the circle. We're asked to find the area of the circle. So in order to get the area of a circle, we go to our maths tables and we're told the area of a circle is pi or squared. In other words, to get the area of this circle, I need to figure out the radius. And obviously the radius is just half of the diameter. A diameter is the distance from IZ to Z. So if I can get the distance from IZ to Z, then I just get half of that, then that's my radius. I'll sub it in, I'll get the area of the circle. Now, the key to this is that this is a right angle triangle. I know this is a right angle triangle because of my geometry. Remember when we were doing geometry, one of the corollaries was that if you have a diameter and if you have a point on the edge of the circle that's standing on that diameter, then it has to be a 90-degree angle. In other words, if this is a 180-degree angle, then the angle at the edge of the circle has to be half of that. Half of 180 is 90. So immediately this is a right angle triangle. I'm going to use Pythagoras' theorem to get that distance. Another bit of theory that's imperative here is that the modulus is the distance between the complex number and the origin. I've already worked out the modulus of z. In the previous part of the question, I worked out that the modulus of z was the square root of 40. And the modulus is the distance between the complex number and the origin. So that distance is root 40. Likewise, I worked out the modulus iz, the distance from there to there is also the square root of 40. Now obviously if I know this distance and I know this distance, I can use Pythagoras' theorem to get the hypotenuse of this right angle triangle. And that's really, really simple here. Obviously the root 40 and the root 40 are the smaller sides and the hypotenuse is the one I'm looking for. So if I sub into Pythagoras' theorem, I can see the square root of 40 squared plus the square root of 40 squared is equal to, let's call it the d squared, the diameter to be squared. The square root of 40 squared is simply 40, so I get 40 plus 40 is equal to the diameter squared. In other words, the diameter squared is equal to 80, so the diameter is equal to the square root of 80. The diameter of this circle is root 80. Now, obviously I'm looking for the radius. I imagine a lot of students would have made a mistake here. Half of the square root of 80 is not the square root of 40. You have to be very, very careful. If you check it out in your calculator, root 40 is not half of root 80. It works differently when they're surds. So the way I would write this radius, the radius is the square root of 80 divided by 2, which is not the same thing as the square root of 40. But once I have the radius of the circle, I simply sub into this and that'll tell me the area of the circle. So once we've identified the radius, it's straightforward. The area of a circle is pi or squared, so it's just pi times root 80 over 2 to be squared. And if you plug that into your calculator, root 80 over 2 squared is 20. The question asked me to leave my answer in terms of pi, so your final answer is simply 20 pi units squared. In part B of this question, we're given root 3 minus I to the power of 9. And we're asked to use de Moivre's theorem to write this in the form a plus ib. You should remember that de Moivre's theorem is a rule that we apply to complex numbers in polar form. Root 3 minus I is rectangular form. So the first thing we have to do is rewrite root 3 minus I in polar form. So let's ignore the power for the moment. Remember, polar form is when you write a complex number in the form or cos theta plus I sine theta, where or is the modulus and theta is the argument. So in order to rewrite this complex number in polar form, we need to find two things. We need to find or, we need to find theta. It's easy enough to get or. To get or, it's just the modulus. It's the square root of a squared plus b squared. And in this case, our a simply refers to the real value, which is root 3. So it's the square root of root 3 squared. And b is the coefficient of the I. In this case, it's minus 1. So it's root 3 squared plus minus 1 squared, all inside the square root. And if you plug that into your calculator, the modulus works out as 2. However, it's much more difficult for us to get theta, the argument. In order to get theta, you need to draw yourself an Argand diagram, where the horizontal line represents the real axis and the vertical line represents the imaginary axis. I want to roughly sketch root 3 minus I on my Argand diagram. So root 3 is obviously positive, and its positive real value is out here. Minus 1i is obviously negative, so the negative part of the imaginary axis will be down here. So this is positive root 3, this is minus 1. I could say my complex number is there. Now we need to form a right angle triangle. So we join our complex number to the origin, and we join our complex number to the real axis. Now we have a right angle triangle, so we're just thinking of junior cert trigonometry. I want to find the angle that it makes with the horizontal line. I'm going to call that the angle A. And based on this diagram, I can tell what the opposite is and what the adjacent is. Obviously, the distance from here to here is 1, which means the distance from there to there is also a 1. The distance from the origin to root 3 is obviously root 3, so that means that this distance here along this line is root 3. So if you look at my angle A, the opposite is 1 and the adjacent is root 3. Remember from junior cert trigonometry that the tan of an angle is equal to the opposite over the adjacent. So I'm looking for the angle A. I could say that tan A equals 1 over root 3. Then you could go to page 13 on your maths tables and just read off the angle, or you could get tan inverse of 1 over root 3. If you plug that into your calculator, tan inverse 1 over root 3, A works out as 30 degrees. And now that I have A, I'm going to be able to figure out my argument. Remember that the argument is the angle that the complex number makes with the positive sense of the real axis. That means you start on the real axis and you go in an anti-clockwise direction, and that is the angle theta. So that entire distance, that entire angle there, that's the angle that I'm looking for. Now, since we know that a full circle is 360 degrees and the angle A is 30 degrees, obviously to get theta, it's simply going to be 360 minus 30. So the angle theta is 330 degrees. You should just think of your unit circle there, what we did in trigonometry. You're just getting an angle in the fourth quadrant. It's simply 360 minus the reference angle. So now I know my or, I know my theta. I can conclude that root 3 minus I can be rewritten as or, which is 2, times the cos of 330 plus I times the sine of 330. And now that I have that, now I'm ready to use de Moivre's theorem. The question was to get root 3 minus I to the power of 9. Or in other words, I need to get all of this to the power of 9. And it's relatively simple to actually apply your de Moivre's theorem. So let's have a look at that now. So remember, to apply de Moivre's theorem, you simply get the modulus to the power, so it's 2 to the power of 9, and then you multiply the argument by the power. So the angle 330 becomes 330 by 9 in both cases. 2 to the power of 9 is 512, and 330 by 9 is 2970. If you get the cos of that angle, you get 0, and if you get the sine of that angle, you get 1. If you multiply 512 by that, your answer, the complex number in the final answer in rectangular form is 0 plus 512i, which means A equals 0 and B equals 512. And that's your final answer for part B.